Hey, what's up, guys? Today let's look at Lintcode 611 night shorties pass. Actually, we already go over this one before, but today we will be introducing another solution, which is the solution 2. Um, in last video tutorials, we're using dynamic programming. In this tutorial, we'll be using BFS because we need to find the shortest path, which BFS is good at this the best. So let's directly jump into this code. Shortest path, this is our entrance, and we'll be taking three parameters. One is the grid, which is the chessboard, and we have the source, we have the destination. And first, we're gonna check the parameter, validity, if they are valid, if this chessboard exists or empty, if the source or destination exists or not. If they're not, one of them not, then we just return -1. Then we calculate the dimension of this chessboard. Then we figure it out. It's m rows and n columns. And we here declared a visited set. We use this to do the deduplication, because when we use the BFS to traverse, to loop through all the data points, we may visit the one we visited before, but we don't want to do that. So we use the visited, this set, to do the deduplication. And here we also have our dir directions array, which I mentioned before. And we're going to declare a Python queue. Here we use the DQ, double-ended queue. This part we need to pay attention to. We put a tuple. Actually, we put the element into this queue, which is the consists of three elements. One is the x coordinates, one is y coordinates, the other one is the length. Actually, is the length from the starting point, because when we put this source, we started from the source, so the length will be 0. All right. So next, we're going to just use the while loop to use the layer by layer breadth first search strategy to find our destination. So we're going to just loop through this queue. When this queue is not empty, we're going to just get the queue's size. The size means that in current queue, we can say layer, and how many elements there, because the queue is dynamically changing. So we just want to access or loop through the layer of that moment. So that's why we calculate the size of the queue. Then we use the for to loop through only that much of the element. We may add some elements later, but we are gonna just do it in the next level. Okay, so we use the for loops, and we first pop out a element. Like I mentioned, the element actually consists of three elements. So first is x, second is y, and third is path length. All right, so once we got this data point and the length, we're going to just check if this guy is our destination. So if it is our destination, then that's great. We just need to return this path length. The path length is the current point, the path length from the source to the current point. All right, so if this x and y, this point is not destination, so then we're going to just try to start from here to access all the data points that we can go, or we can jump, which is we go to the next layer. So here we just loop through all the directions, and we calculate a new data point, and we just have to check this validity of these data points. We write a method which is called check. What does this check do is that the check is going to first check the data points if they're within the boundary. This is detect if they're within the boundary, and also we have to detect if they have been visited before or not, if they're not visited, and if this data point is not barrier, is not one, and we just return true. This data is a validated data, so valid data points that we can jump to. Otherwise, it's going to be false. All right, so if we pass this check and we just put this data points into our queue, and the pass length, from the source point to this point is going to be path length plus one because we jumped one more step, and also we put this data points into the visited. That means we already visited this data point. If in the future we visited this data points again, we won't do anything. We just skip. So this is the whole core logic here. If we found our destination, we're going to return here. If we don't found anything, we don't return in this while loop. Then we just in the outside we just return -1. So yeah, that's the algorithm, and let's just run this. Actually, in this problem, we're facing some memory limitation issues. Because in Python the memory is more strict. It's not like Java. If you use Java, you do this using this algorithm, it's gonna pass. But in Python, it's a little bit weird, so it's fine. The overall strategy is here. Even though when you do the interview, um, it's more about the strategy and the mindset. So it's okay to write out these solutions. Yeah. That's today's tutorial, and thanks. I see you in next video, and also don't forget to subscribe. Thanks, so that you can get my latest updates. All right. Thanks. Bye.